Microphone settings. It takes about 10 seconds to double check. I hear an echo, which means I'm live. Hey, everybody. Welcome to Chai with literally the best of the best. Today, I'm super excited to interview Philipp Singer for the sixth time. For some reason, he doesn't tell me to go away. He doesn't say this is a waste of his time. One day he will soon. I'm worried about that. Philip is literally one of the best Kagglers ever. Just by his rank, we can definitely say that. If I go to share my screen, his profile eventually. Philip is former number one in competitions, which I think everyone would say is one of the most challenging categories. It definitely has, I think, one of the largest number of grandmasters in it. He's a senior data scientist at H2 and has a PhD in computer science. We've discussed his journey many times earlier, so I won't bore him with the same questions. But it's an absolute honor to host you again. Thanks so much for joining me.
Yeah, thanks for having me again, and I'm surprised you're still inviting me. But yeah, happy to always be here. Awesome.
Thanks. So I'll start with my silly questions first. But I'm curious. You, by measure of numbers, you are one of the best. Why are you so humble still? Like you are the best data scientist of our generation. Why are you not like bossy around other people? Why don't you ask me to go away? Why are you so humble still?
Well, I guess when you participate on Kaggle, you have to be humble because first of all, on Kaggle, the best of the best, it gets more competitive over the time. You think you have figured something out, and suddenly you're participating in a competition, and you feel like a newbie again because there's always new stuff going on. There is always what you learned half a year ago gives you the basis for everything, but it will not be enough for the future. So I think that's the exciting thing about this field, that it's so fast and you have never learned enough, which is also I think why so many top Kagglers still continue to Kaggle. Because yeah, you could say, okay, I have reached rank first. I don't know. It was a game for me. I achieved my rank. And I will live with that. But I think people stick to the platform because it still has this learning effect. Yeah. Otherwise, I also just cook my stuff with the same ingredients as everyone else. So some opinion of mine might be valuable. Some other opinion, others have different opinions. So you always have to stay humble in general.
You don't drink extra chai? I thought all top Kagglers drink extra chai, like one extra mug every day.
I drink chai, but I drink coffee, I drink energy drinks, I drink water. So I drink a lot of different things. But chai is part of it. Chai is part of it.
That's good to know. I'll allow coffee because you said chai. So another silly question. Thanks for sharing that answer. Do you still have any Kaggle superstitions? Like, for example, you used to use the team name Zoo. Do you have like any such things, like some funny things that you still do?
That I still do. Yes. So, for example, when you make a submission, right? Let's say it's a kernel competition. You make a submission and you're waiting for the score. I have this notion of checking the score, right? You're excited. You're waiting. Oh, when is the kernel finishing? I want to see the score, right? And it doesn't work for me if either someone of my teammates writes me the score. I get this is not exciting enough for me. So I always put the hand in front of the screen, right, when I'm checking the score, and revealing the digits digit by digit to see the score. So that's something I'm doing since the beginning, and it makes it very exciting to check the score. Like you see, okay, first digit as expected, second digit as expected, and now third digit damn, it was a bad sub again, right? So yeah, that's not really a superstition, but that's a funny thing I do, I think.
I'll try that. Maybe that improves my score in,
Yeah,
in
maybe it
one of the
does,
subjects.
because it's like Schrödinger's cat, right? You maybe it changes while you yeah, I don't know.
I have a teammate who refuses to use any other seed for all of our models. It's not 42, and he like doesn't allow us to use any other seed.
Yeah, I mean, everyone has the typical seeds. I also have them, obviously, for like, yeah, I don't know, doing folds, for example, but I try to change them, because I'm using the common numbers that a lot of people use, right? And I'm trying to be diverse, so I'm not using 42. I'm not using, I don't know, 1337, which is a common one. I don't know, certain numbers I try to avoid and switch them up, so to be more diverse and different to what others are doing.
So, sounds more common than
Yeah.
imagined. So you mentioned earlier that at the top it gets even more competitive on Kaggle rankings. Can you describe, since I missed the opportunity to interview you when you became number one, once you realized you were closer to it, could you maybe describe the path leading up to it? How were the sacrifices like? I'm sure you gave up many nights of sleep, and how was the feeling when you finally saw the number change in your profile?
Yeah, I mean, it's hard to say, right? It's a typical thing. You're a little bit working towards something, then that thing happens, right? And you're excited, but the excitement up to this point is maybe a bit more exciting than what happens afterwards. And you always have to stay, in that sense, coming back to the beginning, to the first question, trying to stay humble and trying to enjoy this a little bit, which is not always easy. I mean, I never really planned on reaching this rank one. It kind of happened in a way. And because you're mentioning sleep, I'm trying to sleep and not sleep. It has always helped me. So I'm not trying to work through the whole night always just to get something working. But yeah, it's hard to say. I mean, I now I'm not even remembering which competition it was even that made me rank one. But yeah, it happened. That was a very successful year where I managed to get a lot of good results. And then it happened, and obviously this was very exciting, and it is in a way a big relief for me, because I'm very competitive, right? So for me, this is personally exciting, and I can work much better when I'm in a competitive environment and I have some comparison. That's why Kaggle works so well for me. And now Kaggle, although it is still stressful, obviously it is less stressful as if I would still have in my head somewhere, oh, I still want to reach rank one. For now, it's not that important, or not important at all for me. So I can work much better competition to competition, instead of only trying to get to the top. And so I can, if I want to do solo competitions, I can do solo competitions. If I want to do teaming, I can team. I don't have to look for the points that much any longer. I mean, I still enjoy getting points and climbing the ranks because I'm competitive. But yeah, rank one is not a goal any longer that I need or personally would want to achieve.
Uh, if you were to point your success to like one thing, if you were to just select one thing, what would that be?
That's very hard to say. I think, I mean, I can tell you one thing, but it is not one thing, but basically trying to be as diverse as possible. So I never so I'm in this area now for a while. I never tried to be a computer vision guy. I never tried to be an NLP guy. I never tried to be a tabular guy. I always tried to be in different areas. And I think now, in this stage of my career, I have a very broad overview of all the different fields, and I can connect them and also reutilize techniques that work in one area better to the other area. And I think nowadays it's very easy for me to get quickly started because I have this broad overview. So it is not one thing, but it is one answer, basically, to be diverse in terms of what I'm trying to tackle.
And that makes sense. If anyone goes through your Kaggle profile, first of all, they will have to scroll a lot to start seeing rank 2 on competitions. You've won many competitions in teams, and I believe with the zoo as well, your first competition was a win. Um, and all of these are through different ones. Recently, a computer vision one, we learn about today's solution, which had a slight NLP bent to it. There are all sorts of different ingredients there.
Absolutely, yes.
Coming to your work as H2O, you're a senior data scientist here. Can you share about the products you're working on now since the last time we spoke, and what are you building?
Sure. So I think so what we try, or I try, is that so in H2O we have kind of this vision to democratize AI. So we play a role as Kaggle Grandmasters, and I specifically, as I'm more in product engineering nowadays, is that we make to our customers available techniques and tools that we use in our daily work on Kaggle in data science projects and try to democratize them. So in that way, for the last year, I'm specifically working on a new no-code deep learning application, which is called Hydrogen Torch. And here we are trying to offer users a no-code environment for deep learning models in the area of computer vision, NLP, audio, and also video. And here a lot of the work that we learn on Kaggle flows into this product. So that's kind of my daily work. I'm participating partly and much less than I did maybe a year ago on Kaggle. I'm trying to stay up to date in research, in state of the art. And then the best practices, as I said before, have a broad overview of what works in practice. We try to put into our products, and this is specifically the product called Hydrogen Torch that I have been working on. And this is to me very fulfilling now, because kind of the journey for me was coming from research, so a very research focused work, then being more applied in a way that I worked in an insurance company. So I did applied work, did even more applications on Kaggle, really on the state of the art level. And now I'm also trying to build product that allows other people to use what I have learned. And I think this journey for me is personally for me really fulfilling, because I have been also here again in different types of work scenarios. And building something that others are using is very fulfilling. This is the same if you work on Kaggle and you have 10 competitions, and there is one competition where the customer maybe uses your model in the end. This is awesome, right? This makes them proud. This is not too common, unfortunately, but this is exciting. And here with like product development, this is another thing where you can really generate impact, I would say, with the work you do.
And Philip has had those impact many times through Kaggle as well. If anyone follows him on Twitter, he tweeted about NFL using his model, his team's model, in and it was broadcasted on the big screen during one of the matches.
Yeah. Actually, at the Super Bowl, it was even on the screen that the model that we built there is heavily used now in these NFL stats that they're using. So yeah, from time to time, there are these real success stories, and they happen on Kaggle, they happen in industry where you work. And this makes one proud. At least that makes me the most proud, right? If that model really is used, or the products you develop and so on. So to really generate impact.
You mentioned earlier about staying up to date with state of the art. You are one of the most active Kagglers on Twitter. Do you use Twitter to find papers, or is it just through competing where you actually battle test those techniques?
Yeah, yeah, a combination of both. So first of all, Kaggle is still a place for me to stay on top. Kaggle is more a place to see what works actually in practice. So it is a good filter already for research that comes out. So research papers are oftentimes really tailored towards specific data sets, specific tunings, and so on. So obviously there's, and I have worked myself in research, is there is a lot of sugarcoating going on, and there's a lot of it's a very competitive field, and you need to make your papers look good, right? So I mean it's a legit way of doing it, and you can read a lot of papers, but you have no real filter of what works. And I think Kaggle is a good place to really understand what is working, specifically across problems, right? So I don't know. So for example, if you know from Kaggle that efficient net works well as a backbone for computer vision problems across settings. This is one thing that you learn. But you see, for example, vision transformers, you see them coming more and more, but you see them a bit more specific for certain types of data sets, right? So you learn this on Kaggle, I think. And otherwise, yeah, Twitter, I read Reddit daily. That's where I get. I don't read, honestly, new papers very frequently, more only when I'm interested in a topic and when I'm working on a new topic. I do some literature research and I read papers, but I'm not a person who wakes up with the coffee and checks the newest papers on archive and or with a chai and reads the papers each day. But yeah, you only have limited time in your day and you cannot do everything. Yeah, so Twitter is definitely also a good place to get some good new stuff that's going on.
Thanks for that answer. Are you still a PyTorch person? Last time we spoke about, in one of the interviews, you spoke about your setup. In one of the competitions, you really focused on making your code more robust. It was with Dimitri, I believe, and you set up proper configurations. You had shared that. Are you still following those? Have you improved upon that since?
Yeah, I think. Yeah, you mean in terms like the pipeline that you use?
General setup, yeah.
Yeah. So general setup. I mean, I think I have perfectionized this at this point, right? So I have my general framework for Kaggle. I have my general, I don't know, approach steps. So I don't need to spend that much time on the setup any longer. I can very quickly, I can set up a training I can get a baseline for any new competition usually within a day, right? And that gets me started very, very quickly. But I'm still continuously learning new things, and I'm sure I have mentioned this in the past in interviews. Is that I think engineering is a very important aspect of data science, and you need to cherish this and try to learn. There's a lot to learn. So I'm always also trying to improve this. So making your models faster, iterating faster on your training, making inference faster, improving your pipeline setup, all of these things. I'm trying to continuously improve.
Thanks for sharing that. You missed the question. Still PyTorch, or are you also using TensorFlow now?
No, sorry. I'm only using PyTorch.
That's good to know you're on the good side.
Yeah, I don't think it's that important. I mean, use whatever works for you. If you want to learn something new, I would still recommend to learn PyTorch, because just I think there's more libraries and more new code out there. But otherwise, yeah, it's not that important, I think.
Okay. I as a YouTuber, I always try to come up with controversial questions. This is one of those.
Sure. yeah, I'm usually trying to be open for everything. I have some strong opinions on some topics. Maybe you will find them, but to ask the questions for those topics. But otherwise, I'm more like, I don't know, more like use whatever works, right? Whatever works for you.
You mentioned earlier about your expertise from Kaggle condensing into products.
Mhm.
So there's some third digit optimization for sure in competitions where the difference is just the
Mhm.
third digit of accuracy.
Mhm.
How much do you find the learnings being applicable to building real world products?
Mhm. Yeah, it's a tricky question in that sense that it depends a bit on your business use case, right? So if you work in a company and it's just the first version of a model and there is not a large business case behind it, it definitely won't convince your managers if the third digit is better to use this model or not use this model. You just have to generally prove the point of value and that this is in general a useful and helpful approach. If there is like a huge, if I don't know, if Tesla makes their driverless agent by 1% better, they are happy, I guess, right? So that's a big thing. If you have a million business savings from your model that you're developing in your company, 1% is already a lot. So it depends a bit on the side. Still, even though this is maybe not that important in a business context, you learn the most in this small span, right? So nowadays, a lot of people can get a decent baseline very quickly, right? But on Kaggle, you're pushed, and if you just work in a company, this is as we just discussed, this is oftentimes enough, and you stop, right? But on Kaggle, you're at least pushing the boundaries, and we all know this, whoever has participated on Kaggle, you hit this wall at some point, right? So you make gains, it gets better, and this is usually a very quick process. And you improve your model, you improve your solution, but at some point you hit kind of this wall. And I believe this is the point where you learn the most how to break this wall and improve this little bit forward. So for personal growth, this is the important part, I think.
Thanks for answering that. Um, Now I'd like to move towards discussing about the competition. So I'll share my screen and try to share what I understood about the problem statement. I actually had a very interesting conversation in the US with one of the people. So they were telling me why some delivery companies even buy location data. So it's like very important for them in cities like New York to optimize where is the best entry point inside a building. This is like an extended version of this competition, but that's why like location data and like collecting and organizing that, as I understand, is like very
Mhm.
important to
Mhm.
some vendors that sell that as a data.
Mhm.
So my understanding was Foursquare is one of such vendors that matches points of interest across locations, and the goal was to like help them improve upon these accuracies. Is this a correct understanding?
Yes. So they have. So I mean, maybe probably most people know Foursquare, right? So they have locations data, and this can be a business, this can be a shop, this can be, I don't know, this can be a historic building, this can be anything. And they are trying to, in this competition, the goal was to match them to a single point of interest with different amounts of granularity. But yeah, so matching individual records to single points of interest.
Okay. And going to the data tab, there's not many interesting columns I was trying to find. I suspect that they might have had images when I first saw the competition launch. They don't. It's just the names of the buildings. Let me switch to column along with latitude, longitude, and address, zip codes,
Yes,
similar
yes,
stuff.
yes, 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 absolutely. So if you think about a company, the easiest thing to map this problem to something that you might encounter in your work is you have like customers in your company. You have the name of the customer, you have the location where that customer supposedly lives, right? And then you try to find duplicate customers. This is a very common problem that happens, and that I have seen in nearly every company I've worked in, is that they have this problem. And in this case, it's just public businesses with a name and longitude, latitude, and you're trying to match them to single records.
Okay. I think that's okay for an introduction. Should we move on to your solution?
Sure. Yeah, I can give a quick summary. So you have, in test data, you have basically a bunch of records. So in this case, in test data, it was 600,000 records. And for each of the individual records, as we just discussed, you needed to find the matching ones in these other 600K records. And then you have to predict for each record what are the matching records. And usually, or easiest you can solve this is that you build a pair between all possible 600,000 times 600,000, which can get super huge, right? Have features for that pair. Let's say the difference in longitude, latitude, the string difference from the first name to the second name. So how similar are the names, and so on and so forth. So you can think of many features. And you can solve this with an LGP model, with a lot of feature engineering. You can solve this with an NLP model. We will get to that. But the problem is that this is very slow, obviously, because you have an enormous, impossible to solve number of pairs. If you do 600,000 times 600,000, you will end up with a lot, both for training and even worse for inference. So how these matching problems are usually solved, or it's kind of a recommendation. In recommendation, it's similar, is that you have first kind of it's sometimes called blocker model, where you try to find the most plausible candidates for a single record, and then only score these K records. So let's say you can do it rule-based, which would be the simplest thing, where you say, I'm just extracting to each record, I'm extracting the 10 closest based on latitude and longitude, other records in this data set. This is a very quick operation. And based on, let's say, Haversine distance, which is just a metric from coordinate difference. And then only do the model on top of these 10, 20, 30, 100 possible records. And the big goal in the first stage is to get a high possible recall, right? So you want to have as few candidates as possible with as high of a possible recall. And if you would take all possible pairs, the recall would be 100%, because you're sure in this 100% of all the records, all of the possible ones will be in, but the second stage model will be too slow. So you have to reduce this as far as possible with a reasonable high recall. And yeah, you can do this first stage model with different ways. You can do it rule-based, as I just described. You can try to build some kind of model around it. And what I did is that I tried to use a metric learning model for that, which is more common usually in computer vision area, where you try to, and here we are back with like combining the different fields, where it is, for example, common in face recognition, so matching faces, right? So you try to build an embedding for a record, then do cause and similarity between the embeddings, and then use that for a similarity metric. Hope that makes sense in a quick summary. And arcface is a specific loss in a deep learning model that tries to optimize these embeddings to make them as close as possible between similar records and as distant as possible between non-matching records. And in computer vision, this is a common loss that it is used for these type of metric learning problems. In NLP, it has been used in Kaggle, for example, in the past, not so much in literature. And in this case, I tried to be a bit different also than the earlier solutions I saw on forums and so on. So I started working on this to do it for NLP, which I already knew worked in a previous competition in Shopee, where it was about matching products to each other with like descriptions of titles. And you can do this in a similar way as in computer vision. So you can use, in this case, a transformer NLP Hugging Face model, get the embedding, and then have a head on top and use arc phase loss to optimize this. Exactly in this Shopee competition, I think it was used quite heavily. There you had images and text, so both. And I used this here in the FourSquare competition. It took me quite some time because the training is quite tricky to get stable for metric learning and specifically arc phase models. But I was lucky to keep believing in this approach, and at some point, so you need to be really stubborn sometimes, and also lucky to make it work. And then it worked, and I used this as a first stage. So I trained a model that learns these embeddings. And that's a very quick operation to do a 600,000 times 600,000 cousin similarity calculation on GPU between these records on the embeddings. And then I cut off to, let's say, top 100, top 50 possible candidates. And this was my first stage blocker model to get the candidates. And then I used the second stage model to predict directly on the pairs whether this is a match or true positive or a false positive. And for this, I also used an NLP deep learning model, which are usually called B encoders. So you put into one record both samples with separators. So you say name of the first business, let's call it business, separator, name of the second business, address of the first one, address of the second one, and so on and so forth. And then you train a model on this to directly predict, is this a match or is this not a match? So this was my second stage model. And for both the first stage and the second stage, what was extremely helpful for me is to directly use or paste in the longitude and latitude to the text and let the transformer model train on that directly. So I just used the longitude, so the float, basically, split it up into buckets of 3 digits, because that's what the tokenizer can work best. Yeah, here you can see an example. So this would be a B encoder example. Exactly, yeah. So you're just separating it with the correct separator tokens, and then you let the model do the job. And so this worked surprisingly or thankfully very well for me. And this pipeline was useful.
So going back, sorry, I got confused a bit. In Shopee, you said people were using NLP models, or was it the metric learning approach?
In where in Shopee?
In Shopee competition, were people using NLP models, or was
Yeah,
it
they were using ArcPhase also for NLP there. Yes.
Okay.
So definitely. So I mean, as I said, it was so you had images and text. So you had an image of a product and the text description. I think everyone used metric learning ArcPhase-like models for the image part. Then for the text part, it was either using simple TF-IDF, getting the embeddings and then doing similarity. But better was doing exactly also ArcPhase-like models for the NLP part. And then you combine both embeddings together. So what we did, we actually trained both at the same time. So you have an image input, you have a text input. You get both embeddings out, right? You concatenate them, and then you have an ArcPhase head afterwards and directly train on both. So this is kind of everything together in a single stage. But what worked slightly better is to do it separately. So NLP, ArcPhase model, image ArcPhase model, and then concatenating the embeddings and then doing the similarity search.
That makes sense.
Yes. So I knew that it works for NLP, but it is way harder to tune than for images usually.
Yeah, I was confused about the intuition about why did you use that. That makes sense. Nischay Dhankar, who has recently joined our team, was also curious about this. So he wanted me to ask, why did you use NLP models? Nischay, that answers your question, so don't bug me later. um, uh, Also wanted to share this from your discussion. You mentioned in your solution discussion, a few of these details are also there in the comments. So anyone who reads this, please also scroll down. There are a few details there. But you mentioned how you struggled with TF-IDF 10 years ago, and now it's like very easy to do all of these things.
Yeah, I'm not sure if I'm the only one, but sometimes I Google for things and I find a Stack Overflow question from like ages ago, and then I'm looking at the username and it was me asking that question, and this was I'm not sure if I'm the only one who encounters this from time to time, but in this case, yeah, I did actually quite some tech stuff in my research, like in my master studies, in my bachelor studies. It was the time when Twitter was coming out, and a lot of researchers started to use Twitter data a lot because it was at that point in time, it was quite openly available. You could get a lot of data, and there was a lot of research on Twitter data at that time. And yeah, and it's textual data, and I sometimes needed also some similarity between texts. And like 10 years ago, you did this by doing TF-IDF, getting a long embedding, right, which is the TF-IDF dimension, and then you calculating causing similarity between these types of TF-IDF or count vectorizer, whatever you used, embeddings. And yeah, I very recently found exactly a question from myself. I think it was 8 years ago or something, where apparently I remember it now. I was struggling to calculate exactly the similarity from like hundreds of thousands of records to hundreds of thousands of records. So exactly this problem. And at that time, GPU solutions were at least not common, right? No one used it. And fitting even this whole matrix into memory was impossible. So you used like sparse matrices, and then it got already tricky with like doing the similarity. So yeah, I was struggling apparently, and I think there was no good solution to it. And nowadays you can do it quite easily in a batched way on GPU, and the 600K times 600K runs through in 30 seconds on a GPU or something like this. So yeah, it's insane. So sometimes I need to remember or remind myself rather how fast of a progress we are making just in a couple of years sometimes.
That's an awesome story. Coming back to your solution, anything else you wanted to highlight in the two-stage modeling approach?
I don't think so. I think in the end the kind of pipeline is straightforward, but sometimes it looks only afterwards straightforward. So it really cost me quite some time, specifically in the first stage. And the first stage was key. Just using the rule-based method to extract was not sufficient enough. I think many people got it to work, but I'm honestly, even though I say I'm multidisciplinary, I currently have more fun trying to make deep learning methods work. So I was kind of, also for learning purposes, I was kind of stubborn to try to make this work. Yeah, but I don't think there's anything else specifically worth. Maybe only that post-processing didn't help here, which usually helps in these kind of problems. But there was some room that I saw in other solutions to maybe do some third stage, which would be with like you have a graph usually then, and I tried a few post-processing things with this graph, like doing query extension, which is common thing. So you try if that one is connected to that one, but that one only to that one. So closing triangles in a graph and so on and so forth. But I saw one other Kaggle doing like graph neural networks as a kind of third stage, and that worked apparently very well. So this is definitely something I want to explore in the future, and which is my learning from other solutions, mostly when reading through them.
Do you save to like apply those learnings in a future competition, or do you like go back to the one that recently ended, or maybe like implement some of those?
Yeah, I usually I have only a good short-term memory, but apparently for Kaggle competitions, I have a very good long-term memory. So sometimes then in future competitions, I remember only that there was something in this competition, and I go back on reading it up. I'm bad with note-taking, so I don't have any strict notes about things I want to take away. So yeah, for me, it's sometimes I forget things, but sometimes I go back to old competitions a lot. But I'm trying to remember what was mainly useful for others in this competition, and then try to look that up in the future again.
So there's a question in the chat, and I'll try to rephrase it. I'm just highlighting it for you. They're asking, how do you like iterate upon your baseline? So in your final solution, you had, I believe, XLM large. Were you using that all the time, or like for that particular example, could you share how were you iterating upon that model, let's say?
Yeah, that's also a tricky question. I mean, usually I try to start with smaller models, but not super small. So I would not start with the smallest DistilBERT model in NLP, but rather, because the tuning is very different from my experience, from like a very, very small model to the larger models.
You change batch size, it stops working.
Yes. So specifically in NLP, the transfer from small to large feels a bit harder to me than sometimes it's in computer vision, in terms of like keeping the hyperparameters similar. So in this case, for me, this was multilingual data. So for me, there are not many options of good models that I know work for these kind of settings. So XLM Roberta is usually at least one of the best models for multilingual data. And in this case, I started with base model, experimented with that, and after a time switch to large. But you have to retune it. So it's more overfitting usually, right? So you need to retune it. So I think sometimes it's a little bit of intuition again to know what works or what should work, and then start from there. But yeah, it's tricky. It's still important to try to iterate quickly, but yeah, I wouldn't like start iterating on 16 tokens instead of 512 if it's longer text, if you know what I mean. Yeah. So make a reasonable start, and then start from there, because otherwise you will not learn much with the quicker approach. But for example, I mean, so there are these Kaggle Days competitions, right? And in these Kaggle Days hackathons, you have 4 hours to build a solution. And I can really encourage everyone to try this, because it's a very different experience versus having 2-3 months for a competition. You need to, and you can see that it also worked out quite well for me. But if you scroll down, you can see that when I started doing them in the beginning of the year, this is also another one. We were starting out with like rank 10th, right? We improved on the next one to 8, to 6, to 6, to 5th. So you can see a nice progress in terms of how we did in these competitions. And now we made second rank, first rank in 3 in a row. So yeah, so we are definitely improving also to do that. And for this, I just wanted to make one example. I think it was an early NLP competition, and I didn't do NLP for too long. And it was 4 hours, and we experimented like 3 hours plus with exactly XLM Roberta base. and then we're hoping to switch to XLM Roberta Large, but couldn't make it in the time, right, to switch to the large model. And others started directly with large and had better scores because it was just working better, and they started earlier with it because they knew it should work better, and they will directly start with it. So this is, if you don't have forever time, it might make sense to also start with the larger ones. But it doesn't mean that always the larger ones will work better.
I think it was the username is Somesh. They had a discussion in one of the competitions where they said for Kaggle Day specifically, if it doesn't work in the first 10 minutes, it won't work in the remaining 4 hours.
Yeah, fair enough. Yes.
And also for the audience, so our dream rank, which is I think somewhere in the gold 10, is bad for Philip. Please remember that. He said it's a bad rank. Um, Coming to your solution, anything else you wanted to highlight? The CV, the cross validation setup was straightforward, so I'll request everyone to read that up. And there was a controversy in this competition, which I'm skipping, unless you want to cover it.
Yeah. Yeah, so this was a tricky competition in terms of cross-validation setup because so in matching problems, you will have a harder time the more candidates you have, right? So if you have only 10 candidates and you need to, exactly what we mentioned with this first stage approach, it will be easier. So the more other candidates you have, so the more data you have as possible values, the harder it will be. And in test data, we had 600,000 records, and in training data, it was exactly double, roughly. So let's say 1.2 million. So to have a reasonable cross-validation setup, you needed to do 600,000 training. So you needed to do it twofold, right, only. And that already removed half of your training data, which is not ideal, specifically for deep learning models. You want to use as much as possible. So when I saw good correlation from this 50-50 splits to LB, I decided at some point to switch to evaluating only on leaderboard, which turned out to be good and bad because there was some leak, unfortunately, in this data. But I still stand to the point that this was, given the setting, it was the most reasonable thing. So on Kaggle, you need to figure out, you need to play the game a little bit, and you need to figure out if public test data is a good validation set, and oftentimes it is even the best validation set, or if it's better to try to stick to cross-validation because the public LB is maybe shaky or not so reliable for private. In metric learning problems, it usually has been historically a very reliable type of setup, because also you're matching in this public set also versus the private set. So you have kind of a mix already in a way. And in that sense, usually it's a good strategy to at least consider evaluating also on public leaderboard.
Thanks for sharing that. Again, we didn't go into detail because I felt it's quite clear in the write-up. Again, it's the top link in the description in case anyone wants to read the solution write-up. Anything else you wanted to highlight in your solution?
Probably there's nothing else. So here I'm just writing that in the end, I'm blending the first stage and the second stage. So I'm not only using the first stage to get the candidates, but also I blend the Cosin similarity probability with the B encoder probability in the end, 50-50. That's maybe the only other thing to mention. And yeah, as I said, there was a leak. I will not go too much into detail about that. So if you want to read up on some drama, you can be entertained in the forums. But they also posted afterwards that there is unfortunately only for a couple of people, they posted the unleaky a leaderboard, although I don't know how exactly they calculated it. So I'm not sure how representative it is, honestly. And yeah, here you can see that apparently my pipeline, even though I only focused on public leaderboard, so on the leaky part, held up really well also on this unleaky data. So I'm a bit. It is unfortunately for the whole competition because I still think it's a very interesting problem. The data was, by the way, synthetic. Even though it was synthetic, it was, I think, very interesting data and interesting setup. So it's a bit unfortunate that there was a leak. But yeah, and for me, it's unfortunately because I didn't push the unleaked data enough. So I'm curious how far I could have pushed it, but I'm still very satisfied in the end that it also held up really well on the unleaky part.
I think that goes to show the robustness. And in your write-up, you also mentioned you genuinely think that this pipeline that you created would be also useful for future competition. And it just goes to establish the point.
Yes.
Awesome. So now I'll move to general audience questions. These will be quite random and in different order. Does this ever happen to you where you like look at the leaderboard and do you at all look at the leaderboard and see like novices above you on the leaderboard, and does that intimidate you at all?
Yeah, I don't like being high on the leaderboard early on, but sometimes it happens. So it 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 takes I feel like having more pressure being high on the public leaderboard because all your friends see it, everyone else sees it, right? And if you drop afterwards, it's usually disappointing, rather than, let's say you are first the whole competition and you drop to fifth. Everyone says, oh, poor you, right? You dropped from first to fifth. But if you're like 20th or not on the leaderboard at all and you jump to fifth, it's yes, awesome, right? So it's a little bit of a social phenomena. And also there is a lot of meta going on the Kaggle leaderboard. I cannot even describe it, but top Kagglers can usually understand or get information from the scores of other people. So I can tell you that top Kagglers not only monitor the submission times of others, they monitor how much of a jump others are doing, and you will be surprised, or probably how much information you can get out of it, right? So, oh, that person has a very short submission time. It's probably an LGB model. Yeah. Oh, that person has 8-hour submission time. Oh, that high score is already a blend of many deep learning models, right? So stuff like this. And specifically, if there's a gap on the top, people will know that they are missing something and will dig deeper into other parts and spend more time because they know that there is something in the data that they are not finding yet. So yeah, it can give a lot of information. So I still personally sub a lot usually, but if possible, I'm trying to stay down a little bit. Yeah, due to several reasons.
I want to share two interesting stories that were discussed on the podcast. So Chishin, whom I interviewed 2 days ago, in the TensorFlow competition, he posted "Good luck, everyone," and his team was 100th 1 day ago, and they jumped up to first.
Yeah, exactly. And in that competition, for example, we dropped. So yeah, this was a competition, for example, where the private leaderboard was completely different to the public leaderboard, which I'm personally not a fan about, because I'm not sure how reasonable this is in a business setting. But yeah, so it's you can have luck, you can have bad luck. It usually balances each other. It balances it out the more you compete on Kaggle.
The other story I had, I'll say that very quickly. So Ahmed had shared this. He also does this social engineering where he looks on the top of the leaderboard and he knows which Kagglers favor which techniques. So
Yes.
he figures out, oh, this it's Philip on top, so maybe he's using deep learning. Let's say.
Exactly, for sure. So if I would have been top the whole competition, people would have, for example, looked more into deep learning models, for example, right? or you can look at some other competitions and understand what kind of models are maybe, or solutions are maybe used more.
Awesome. So I'm just scrolling through interesting questions. How do you select? Looks like we lost Philip. I'll just wait for him to rejoin.
I
No
dropped.
worries.
I'm back. Sorry.
I've had very interesting stories where my monitor would turn off, and
Yeah, I don't
in
know.
one of the,
My window closed. I'm back.
uh, so the question I was going to ask is how do you select which competitions to take part in today?
It's a hard question. You try to find competitions that are not luck based, which already means I will not do time series competitions usually. This is the first kind of. Then I have had synthetic data, even though FourSquare was synthetic data and it turned out to be problematic in the end, and I'm trying it again and again, can be also an indicator that there can be something fishy or unlucky in the end with synthetic data. But in the end, you never know upfront how the competition will turn out. Because also what I mentioned earlier, like if the private leaderboard is completely different data, which has happened in the past, everyone will just stumble in the dark and someone will be lucky or unlucky in the end. And I'm not sure how useful this is. I enjoy competitions where you try to generalize to different data, right? Which is the private data is different, but then I prefer it to be communicated upfront so that you can try to go into this direction and try to generalize. But yeah, I actually saw yesterday or something a tweet about trying to calculate the ratio between luck and skill needed for a competition. It was from a Japanese Kaggle, I believe, and it has to be above a certain ratio, but it is hard to calculate upfront. But yeah, definitely prefer competitions that involve more skill than luck. I have a hard time stopping doing competitions, but sometimes it would be the best strategy because I still care about the cleanness of my competition list. I don't like having bad results in there. But maybe at some point I need to stop caring about that and also stop doing competitions when I understand quickly that this will be a problematic or more random competition.
For the audience, I want to highlight that Philip has 0 bronze medals on his profile, which I think is very rare on Kaggle.
Yeah, I will try. And I think
Awesome.
we talked about this a year ago or something already,
Yes.
and I'm still trying.
I believe it was you or Christoph who scolded me because I said I tried to like gather useless points by like submitting top kernel. And you said don't do it. It's like this not the best use of your time. So since then I have stopped doing that.
Yes.
Before I ask my last question, I'll point audience to all of your profiles. So if you head to Kaggle profile, Philip's Kaggle profile, you can find all of the links, his Twitter, his GitHub, his LinkedIn, his website there. I'll highlight those as well. You can head over there, connect with him anywhere on the internet. He's always sharing his solutions. So it's very high signal things that you can learn. He's always sharing very knowledgeable stuff. I don't think he shares any memes. I haven't seen him do that. And here's his Twitter link. I'll ask one selfish question. I know you don't watch this series a lot, but as my senior colleague, what would you like to see on the series, or like what's one form of content that you would like me to make?
Hard to say.
I don't ask this to hear praise from you. I genuinely like want to get to a level where I can create something that you might watch.
Yeah, I don't know. So, for example, inviting a few Kagglers and just discussing gossip topics could be fun. So there's a lot of discussion going on about some stuff, right? And people have so many different opinions about, for example, a league I don't know, some drama going on Kaggle. I know this is maybe not too interesting from a technical perspective, but it could be fun content. Fun content to discuss this, and more about also as I said, people have different opinions and different experience even about technical things, right? So you can find some topics, like let's say early stopping is a topic where so many people have different opinions about finding best checkpoints, early stopping, so things like this, and having maybe a round table of a few people and discussing these topics. That could be fun.
Awesome. I'll make that happen. I'll have a best practices and one controversial panel ASAP. Philip, thank you so much again for joining me on the series. It's an
Perfect.
absolute honor for everyone to learn about your journey.
May I answer one more question in the chat?
Sure, please.
Because there was one from who I want to mention from Tubo.
Sure.
Because I want to mention him because if I'm not mistaken, he's the one with the who did the graph neural network that I mentioned earlier, and he did. For example, he did extremely well in the Unleaky solution. So definitely check out what he has been doing, and he has been very kind to answer to also describe his solution. And he asks, I would like to know if you have any tips for metric learning. So maybe I can just quickly also emphasize this. I tried to answer it already before, but as I said, the training is quite tricky for metric learning. And here you can really use a lot of tricks to make the training stable, like having long warm-up. Then very important is sometimes to use differential learning rate, meaning that you give different layers of the network different learning rates. And here specifically, the arc phase head sometimes needs much higher learning rate to not overfit so heavily. Then you need to do a lot of optimization in terms of margins and scale for the arc phase loss. And I think also in Shopee competition there has been maybe, or in the Happy Whale maybe also have a few tricks been mentioned, like changing the margin across epochs to increase the margin, and so on and so forth. So I just wanted to quickly also mention that.
Thank you very much. Again, for the audience, Tubos is the 13th position solution on the competition, so you can read the details there. I thought they joined late, that's why they missed the part where you would explain that, so I skipped the question.
Sorry.
Awesome. I'll again highlight Philipp's Twitter and Kaggle profile. Philipp, thanks again for your time.
Thank you.
Thanks everyone for watching.
Ciao.